Good morning, guys. So Unit 7 is going to be on right triangle trigonometry. So this first section, I'm calling it 7.0 because we are just going to be kind of laying some background work for what we're going to need for this unit. Also, we are going to be reviewing the Pythagorean Theorem. Okay, so those are our goals. Our objectives, are to recognize the sides of a right triangle relative to the reference angle. So we'll see what that means in a moment. The second one is to use the Pythagorean theorem to find the missing side of a right triangle. All right, so what is a right triangle? A right triangle is a triangle that has one right angle, one 90-degree angle in it. So the right angle is usually marked with a box, so I don't think that's new information for anyone. The two sides that come together to make that right angle are called the legs, and the side that's across from the right angle is called the hypotenuse. Now the hypotenuse is always going to be longer than the legs, so it's the longest side as well. So the legs have special names. Usually when we're using Pythagorean theorem, we just call them both legs. But if we're using right triangle trigonometry, which is what we're going to be learning this unit, then we're going to need to distinguish between those two legs. So we're going to call one of the legs the opposite side, and we're going to call the other leg the adjacent side. Okay? Now opposite is just what it sounds like. Opposite, if you're opposite from something, like if it were this angle right here, this leg right here is opposite because it doesn't touch that angle. Adjacent means right next to, so if I'm looking at this angle right here, this leg is right next to that angle, so this would be the adjacent leg if this were the angle I'm looking at. Okay, which brings up the point that the angle of perspective determines which side is which leg. So, notice that these two triangles are exactly the same. This one is telling me that my angle of perspective is angle A, so that's this angle right here, which I'm going to mark. And then this one is telling me that my angle of perspective is angle C, which would be right there, right? So the hypotenuse on both of them is going to be that longest side that is across from 90. It's opposite of 90. Okay, so that's true for both. So that's not going to change based on my reference angle. But if my reference angle is this one up here, this is A, then the side that would be opposite of that would be the one that is across from it that doesn't touch that angle. So this is the opposite leg. And this one would be the adjacent leg. Now one way to determine, well, I guess if you're finding all three of these legs, the first thing I like to do is find the hypotenuse because it's usually kind of the easiest to find. It's the longest side. It's the one that doesn't touch the right angle. It doesn't come up to help make the right angle. So find the hypotenuse first. Then put your finger on the reference angle. So if my reference angle is A, I would just put my finger on that angle. And then the side that I'm not touching, because if I put my finger on that angle, I'm touching this side, A to B, and I'm also touching this side, AC. The one I'm not touching, that's the opposite leg. Okay? And then the third leg that's left over, the one that helps make up that angle, that's not hypotenuse, that's the adjacent, that's the adjacent leg. Okay, so now look at this other one. So I still have the same hypotenuse, but now I've changed my reference angle to angle C. And so because of that, now the opposite leg would be AB. Okay, so think about it. Put your finger on angle C. You're touching the hypotenuse, and you're touching this other side that comes up to help make that angle. The one you're not touching, that's the opposite leg. And then the leftover one, the one that comes and helps make up angle C, but is not the hypotenuse, that's the adjacent leg. Okay. So on your worksheet for today, it's going to ask you to identify the sides. So you're going to have to look at the triangle, see which angle is marked. That's going to be your reference angle. It may be marked with a line like this. It may be marked with a question mark. But that's how you're going to know which angle is your reference angle, the one that has some kind of marking in it. And then you're going to label opposite, adjacent, and hypotenuse on each triangle. You can also color code it if you want. So you could get like red for opposite. So you could make a little key up here. So the opposite is going to be purple. And then you could say the adjacent is blue, and then you could say maybe that the hypotenuse is red. So once I've identified the sides, that I'm going to come in here, I'm going to highlight the hypotenuse with red. I'm going to highlight the opposite with purple. If I can find the purple again. So just kind of trace over the line, and then the adjacent side I'm going to highlight blue. So that's what it means when it says to color code the sides, is make a little key and then highlight the sides that are that color. Okay. Next thing we're going to do is remind ourselves about Pythagorean Theorem. So this should be review. A squared plus b squared equals c squared. So in the Pythagorean Theorem, these two on this side, these are the legs. So if I take one leg and square it and add the other leg and square it to it, that's going to equal the hypotenuse squared. Okay, so that means that every time you use this formula, C has to be the hypotenuse. Okay, A and B are legs. It doesn't really matter which one you use for A and which one you use for B. Like I could say, okay, A equals 3 and B equals 4. Or I can change my mind and say, I want A to be 4 and B to be 3. It doesn't matter which leg you call A and which leg you call B. What does matter is that every single time, C has to be the hypotenuse. Okay? So in this case, I would say that 3 squared plus 4 squared, if I take the legs and square them and add them together, it's going to equal the hypotenuse squared. 3 squared is 9, 4 squared is 16. So 9 plus 16 is 25. So 25 equals c squared. So that's what this side squared is equal to. To undo the squared, I would have to take the square root. So I know that c is 5. So this side would be 5 if this one's 3 and this one's 4. Okay. So let's just do a couple more examples. So again, I'm trying to find the hypotenuse here. I'm not sure why my marker's being so weird. So my legs are 15 and 8, so I'm going to square each of those and add them together. So 15 squared plus a squared equals c squared. 15 squared, I want to say is 225, but I'm going to hurry and grab my calculator and check it. And yes, it is 225. 8 squared is 64. Oh my goodness, this marker. So 225 plus 64 is 289. And the square root of 289 is 17. So 289 equals c squared. To get rid of the squared, I'm going to take the square root. So c is equal to 17. Oh wow, I don't know why it's doing that. Okay, c is 17. All right, so now let's look at one when the hypotenuse is actually what we're trying to look for. I'm sorry, no. The hypotenuse is given and we're trying to look for one of the legs. Okay, so again, remember, C has to be the hypotenuse. So when I set up this equation, a squared plus the other side 7 squared equals the hypotenuse squared. So where C was in the equation, that has to be the hypotenuse. So this would be a squared plus 49 equals 121. Subtract 49 from both sides. So a squared equals 121 minus 49, which is 72. And then the square root of 72 equals 8.48, so I'm going to round it to 8.5. And since everything's in inches, it would be 8.5 inches. Okay, or alternatively, if you didn't want to round it and give an approximation for the answer, we could go ahead and just, I'm writing it over here even though it's the other side, but I could actually write it as square root of 72, and then I could reduce this down like we've done and keep it in exact form. That would also work. So I have 2 2s and 2 3s, so I can bring a 6 out front, and then there's 1 2 left inside. So I could also say a is equal to 6 times the square root of 2 if I wanted to keep it in exact form. Okay. All right, so here we're finding the missing side. We don't have a triangle drawn here, but we know that the legs are a and b, so this would be 2 squared plus 6 squared equals c squared, or 4 plus 36 equals c squared. So 40 equals c squared. So c equals the square root of 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So because there's two 2's, I would bring one out. The 2 times 5 has to stay in. So c equals 2 times the square root of 10. Okay. Here we have a is equal to the square root of 11. So that's my first leg. I'm going to square that. I'm going to add b squared to it. Remember, the c always has to do the hypotenuse. It's always across the equal sign from a squared plus b squared. Okay. Now if I square 11 squared, square rooted, those are going to cancel out, and that's just 11. So 11 plus b squared equals 47. Subtract 11 from both sides, and b squared equals 36. And then take the square root of that, b equals 6. Okay? So the only other thing you're going to be asked to do is you're going to be given a triangle. You're going to be given all 3 sides of the triangle, and you're asked to determine if the following 3 sides of a triangle form a right triangle. So could these be the sides to a right triangle is what it's asking you. So what we need to do is find the longest side, so in this case 15, and we need to call that c, so that would be our hypotenuse. The other 2 sides are a and b, the legs. And we need to see if it's true that a squared plus b squared equals c squared. We need to see, is this true? If it is true, this is a right triangle. If it's not true, this is not a right triangle. So let's do 9 squared plus 12 squared, and we're trying to check, does it equal 15 squared? So 9 squared is 81, 12 squared is 144, and 15 squared is 225. So 144 plus 81, just grabbing my calculator here, equals 225. So because that equals 225, it is a right triangle because, yep, they match. So yes, this is a right triangle. So 9, 11, and 115, I would have to take the square root of 115 to see if it's bigger than any of these other sides. So the square root of 115 in decimal form is 10.72, which makes it smaller than 11. So this is C, this is A, this is B. So 9 squared plus square root of 115 squared equals 11 squared. So 9 squared is 81. If I take the square root of a square, it cancels out. So this would be plus 115. And this is 121. So I can already see that this is a much bigger number than this. So those are not equal. So this is not a right triangle. Okay? I'm not going to do the last one, but I think we get the point. So go ahead and try those. If you have any questions, please email me, and I can get some help for you. So have a great day, guys.